Okay, so I'm going to go through some problem solving examples now and really proper graphing techniques. So, a few things. Let's say you got like a bunch of like data like this, and I told you to plot it and tell me the velocity. First thing you got to do is choose a suitable scale. This one kind of confuses people sometimes. So, what I do is I kind of look up here and go, okay, the top it's about to 50, you know. So I made my scale go up to 50. It might not be the best scale just because this point I had up here is actually a little bit over because of that. I could have went up to 100 or something too, but it's the easiest if you make things like, it would be kind of stupid to make it go up to, I don't know, 52, you know, just because that wouldn't be like even increments to go up by. So what I want to make it go up by is 10, right? So every tick going up here represents 2. So it's 2, 4, 6, 8, 10, up to that point. That's an easy one for me to kind of figure out. If you made every tick worth 3, that's starting to get a little bit more complicated. So I'd kind of avoid that if you can, but it still works. Okay, so choose a good scale. Plot the points. Draw a line of best fit. One thing students want to do is they want to connect all the points. So they'd be like, okay, I'll draw like, from there to there, there to there, there to there, up, and then something like that, right? That's useless to us in physics. What we want is a straight line so we can make sense of it. So what we want to do is make a line of best fit. And really, for the most part, you want to just have about the same number of dots on each side of the line. It's kind of a good general way to do it. Um, yeah, so do that. Choose 2 points on the line, not the original data points. So you can see that I've chosen where these two X's are. So there and there should have been like right on the line. Those weren't my data points because I don't want those data points because they might not be exactly on my line of best fit. So I'd like what I do, what I usually try to do when I choose these points is I choose points that are going to line up, perfectly at somewhere easy. So right on that part and right on, this one's like there, but I would have chose maybe, yeah, I guess that'd be pretty good too. And then use those 2 points to calculate the slope and find the velocity. So from those 2 points, you could draw a triangle like I was talking about before. This is our rise on the right and run on the bottom. Okay, so the rise in this case is going up, and it goes up 30. So I guess this point should have been down 1, so it's off a little bit on my picture. But so it goes up 30 meters. Okay, so that's where I got that top number from. And my run here is going to be 20 minus 5, so that's going to be 15 seconds. You could, to figure that out, hopefully you see where I got 30 from there too. So I went 40 up to there, and there was 10 right there, right? So 40 minus 10 gave me 30. Okay, so then I got 30 over 15 seconds. So my velocity here is going to be 2 meters per second. Okay, so that's a general idea how to do it. So a couple of things, like I said already, always use a scale that's easy, I'd say. You don't always need to use the entire sheet of graph paper too. It's fine if it's kind of small in your graph paper. Always use a ruler. This drives me nuts when kids don't use a ruler for some reason. You're not being very accurate if you're not using a ruler. The line of best fit is more important than the points that were used to make the line. So what we really are after is a good line of best fit. That's the most important thing for us. And then show all calculations. So kind of like I did up here, right, to figure out what your velocity was, including your units. So now I'm just going to go over a few general how to read graphs or read and interpret graphs. So it's still a position versus time graph. Part A says what is the average velocity of the object plotted on the graph? So average velocity, if you figure out the rise over run, so my rise was 15 meters. My run was 40, it's all the way, right? 40 seconds. So my average velocity is 0.38 meters per second, and positive because it's going up. Okay, so what is the velocity of the object at 5 seconds and at 15 seconds? So all you got to do is look at 5 seconds, and that's that point right there. So it wants to know what was the velocity at that point and what was the velocity at 15 seconds. So at that point. So kind of a trick question here though, because we're dealing with constant velocity. This thing has the same velocity the entire way, right? It's a straight line. Some people might look at this and be like, yeah, but the line's getting steeper and steeper. That's just showing that your position is getting greater and greater. Your velocity, since we have a straight line, our velocity is the same the entire way. So it's going to be 0.38 at 5 seconds and at 15 seconds. How far did the object travel during the 10-second to 30-second time interval? So we're looking from 10 seconds, so from here to, what was it? 30 seconds. So from there to there. So all you have to do there is just line it up. So at this point, my position was 4, right? It was at about 4 at that point. 30 seconds was at about 11. And down here, I was a little bit more accurate. I said 3.7. That might be a little bit more accurate than we could be, but we'll do it. 3.7. And then, what do they say down here? 11.1. So if we want to figure out the difference in the distance there, all you have to do is subtract them. So 11.1 meters minus 3.7 meters, so 7.4 meters. How far would the object travel over 25 seconds? Don't overthink this one. You just have to look at 25 seconds, draw a line straight up. What's the distance at that point? So, I don't know. You have to kind of do a little bit of guesswork there. I said 9.2 meters. How long would it take for this object to travel from 6 meters to 10 meters? So all we have to do here is erase some stuff here. 6 meters to 10 meters. So I'm going to look at the 6 meters. That's right there, right? Is where the point would be. To 10 meters. It's going to be right there. Okay, so then, if you draw a line down from there to there, the times are going to be 16 seconds and 27 seconds. So if I want to figure out how long it would take, all I got to do is subtract those two numbers. And that is what we did down here. So 27 minus 16, it would take 11 seconds. So I'm going to end that video there so we can pick up fresh with the next topic. So I'll see you guys in the next video.